In this video, we'll begin the unit of exponential functions. Before we begin with exponential functions, we want to work with exponential expressions first. So last year and the year before, you learned some exponent laws. So we're just going to review those ideas and we're going to simplify some expressions using these exponent laws. So in grade 9, you learned the product law of exponents. So I've written an example, the general form of the product law of exponents, but what you probably remember is the teacher saying when we multiply powers with the same base, we add the exponents. Okay, when we multiply powers with the same base, we add the exponents, which makes sense because when you have a power and you look at the exponent, it just tells you how many times you're multiplying, in this case, x by. So if it's x to the power of a times x to the power of b, then yeah, it makes sense to have a plus b factors of x. That's how many times you can multiply x by itself by. All right, quotient law. So now instead of having more factors of x, you're actually losing because you're dividing. So it makes sense to subtract instead of add. So when we divide powers with the same base, we subtract the exponents. Okay, power law. Okay, so this is the third grade 9 exponent law. So product law, quotient law, and now power law. So this is the general form here. When we have a power of a power, we multiply the exponents. So you really have three options here. You either add the exponents, subtract the exponents, or multiply the exponents. All right, and then in grade 10, we gave you two more exponent laws. We gave you the zero exponent and the negative exponents. So any number except 0 raised to a power of 0 is equal to 1. All right, negative exponents. So you know that a positive exponent means you're repeatedly multiplying by a number. Now what about a negative exponent? Well, think about it. Positive and negative, you can think of them as opposites. So if positive exponents, like, I don't know, let's say 2 cubed means you're going to multiply 2 by itself 3 times. So like 2 cubed is 2 times 2 times 2. What about 2 raised to the power of negative 3? So instead of multiplying, we are going to divide, okay? Negative exponent tells us to repeatedly, so instead of repeatedly multiply, we're going to repeatedly divide by the base. So that's I guess that's it may not be intuitive in the beginning because a lot of students, when they see a negative exponent, they think like the result is negative, but that's far from the case. What it really tells you is that you're repeatedly dividing. So it's 2 to the power of negative 3, you're dividing by 2 3 times, as opposed to 2 raised to the power of 3 means you're multiplying 2 3 times, so like 2 times 2 times 2, as opposed to divide by 2, divide by 2, divide by 2. Anyways, so that covers your exponent laws from grade 9 and grade 10. I actually did a recording of my solution, but I didn't realize that it actually took a lot longer than I wanted to. So instead of boring you through each and every single question and you watching me write the solution, I think it's better if I just show you my solution. Well, you try the questions yourself first. So try all 33 questions, and then and you can look at my solutions, and hopefully we have the same answers. Okay, so for all 33 questions, my strategy was follow BEDMAS and use the appropriate exponent law, whether it's a product law, quotient law, power law, zero exponent or negative exponent, just use the correct law. So for questions 1 through 5, not much to say. Yeah, just follow BEDMAS. 6 through 10, not much to say there either. I may have like saved a few steps here and there, but as long as your final answer is the same as mine, then I guess we're both correct. Well, hopefully I didn't make a silly mistake, but I'm feeling pretty good about my answers. Okay, 11 to 15. Yeah, not much to say. Let's see, 16 to 20. Let me see. Yeah, 16, 20 is pretty straightforward too. Not much. So like here, x to the power of negative 1 times x, that's just 1. You can think of it as 1 over x times x simplifies to 1. Or you can add the exponents negative 1 plus 1 is 0. But no matter what you do, you get this, the denominator simplifies to 1. Okay. For 21, it looks challenging, but if you just take your time, follow BEDMAS, you'll be fine. Okay, for 22, now, if a student left it as x to the power of 10 minus 2r, I guess I'll accept that answer, but 10 minus 2r is not written in standard form, so really, you run it as minus 2r plus 10, but then you realize like minus 2r plus 10, we usually have the coefficient, well in this case of the r term, we want it to be positive, so I factor out negative 1, and that leaves me with negative exponent. So that brings me to what I have written down here, 1 over x to the power of 2r minus 10. Okay, anyways, when you multiply, add the exponents, so same idea here, I factor out negative 1. Like I said, if a student didn't do, like these questions are not very common for the next few lessons, so I'm not too crazy. Like if a student left it as at this step over here, or they wrote it like this, I'm indifferent. I can live with both actually. Okay. Alright, so what do you have here? 25. Yeah, same thing, factoring the negative 1. Not much for 26. Well, 26 actually, I don't know if you see I'm skipping a step, but you may have learned this in grade 10. So what you can do is take the reciprocal of the base, and your exponent will go from positive to negative or negative to positive. So in this case, I took the reciprocal of the base, so it's now x, which means the negative 7 exponent becomes positive 7. We're going to go over that again. That I don't know if we want to call it a shortcut, but we're going to go over that rule when we talk about rational exponents. For 27, not much. 8, not much. Yep, pretty straightforward. So far, so good. For 32, so I did the same thing. I had a negative exponent here, negative 3. So I took the reciprocal of the base, and now it becomes positive 3. Aside from that, there's nothing crazy I did. Now 33, this, of all the questions, this I would argue is the most interesting to me, because this, you can make the argument that you can't do this question, because you've never seen, well, maybe you have outside of like, regular day school, but you've never seen in the textbook of grade 9 and grade 10 a rational exponent. Okay, this is an exponent of 1/2. Now if you think back to the first chapter, you actually saw that. Okay, when we did radicals, you've seen an exponent of 1/2. But anyways, this is just I don't want to foreshadowing what's to come, because you will see rational exponents later on in the unit, and really you treat them just like any other exponent. You apply the same rules when you do the product law, quotient law, power law. Even though it's a rational exponent, you still multiply, or you still add, you still subtract. Okay, so multiply, because power law of exponents, you can add and then subtract. And you should get what I got. Okay, so that was a very quick review of your grade 9 and grade 10 exponent laws, and we'll definitely need them to work with the expressions in this chapter.